In this video, I will do the review of the topics that I collectively refer to as Precalculus, and the main objective for the viewer is to understand the place of Precalculus in the landscape of lower division math courses and to be able to identify the main subjects of interest and tasks learned in Precalculus. Now, previously I have shown you this layout, or what I call the landscape of lower division math courses, and you can see that the Pre-Calculus, Calculus 1, Calculus 2 form the sort of pipeline from the beginning of mathematics into the large field of lower division math courses, and Precalculus sits right at the beginning of this pipeline, and it is naturally a, a prerequisite for Calculus 1. So coming out of Precalculus, you have to be ready for Calculus 1, but also Precalculus serves as a collector or as a merger of two branches, one being geometry trigonometry and the other one being arithmetic pre-algebra algebra. So somehow in Precalculus we have to develop a unified approach to previously learned math. And as you may already know, that the main subject of interest in Precalculus is functions. So in this video, or in Precalculus, we learn functions. And this, what we call Precalculus review, will actually end up being functions review. And to start, we have to first be able to list all different types of functions. And you can pause the video here and try to list them all out, and I will reveal all of those functions in a second. So here's the list of all types of different functions that we learned coming out of Precalculus. Here you see your familiar 8 functions coming out of algebra branch, and here we have trigonometric functions, and there's many of them. There are 12 of them, but collectively we'll just refer to them as trigonometric functions. And what does it mean to know each of these types of the functions? So here's what I'm calling a knowledge matrix. So every piece of knowledge that we acquire about functions will belong somewhere in this matrix, and the rows above this functions line are labeled as operations, expressions, and equations. And I did a brief review of arithmetic in which I discussed all operations that are out there. And in that review, I think I said that operations are predecessors of functions. And now we kind of see how exactly they become functions eventually. And the next review I did was on pre-algebra. In pre-algebra, we learned how to handle each of the different types of expressions. And guess how many expressions types are there? And there are exactly 8 of them, and the names are exactly the same as the names of functions. So naturally, you have to be able to work with expressions before you learn any of the pre-calculus. Also, I think I made the point that expressions are building blocks, meaning that we use expressions to create equations, and you already know that we also use expressions to define functions. But equations I discussed briefly in the video called Algebra Review. So in that video, we talked about different types of equations, and what is there we do with them? We solve them. We also discussed inequalities and systems there, but those will come up eventually, but the biggest objective was to learn how to solve equations. Now, all the trigonometric stuff we learned or reviewed in the lecture called Trigonometry Review. So this video will not be focusing on trigonometric functions, but mainly focusing on the 8 functions coming out of the algebra branch. And what does it mean to say that I know this type of function? That means you know how to answer all of these questions. That is, you know, you can make a statement about different forms of each type of the function. You can discuss how to graph this function. You can discuss the domain and range. You can discuss the intercepts. You can discuss the asymptotes, continuity. I'm just listing it all. I will provide more details in a brief moment. So let me just finish the list. That means you can discuss the monotonicity, whether the function is one-to-one or not, whether it's symmetric or not, whether it has any special features, and you should be able to find an equation of this function given some information, and you should be able to know basic applications for each type of the function. So eventually you should be able to provide details in all of these, let's call it cells, right? But remember what I said earlier, this is like your knowledge matrix. So everything you learn goes somewhere here, right? And it should go both ways. I can ask you to identify where does any of the skills that you acquired earlier belongs in this matrix, or I can ask you to provide more details for any of these intersections of rows and columns. So let me briefly go over what does it mean to know the operations, expressions, equations, etc. And let's start with operations. So when we discuss linear function, for example, we will discuss what kind of operations are there. And the idea is that there are altogether 8 operations that we identified in the algebra branch. Then in trigonometry, we identified another 12. And naturally, you shouldn't be surprised that those operations kind of turn into functions. So you have to know what is the predecessor for each original function with all of the consequences. Such as you should know the properties of logarithms, for example, way before you start discussing logarithmic functions. You should know the properties of exponents way before you start discussing exponential functions. All right, next. Expressions. What is an expression? Expression is anything that you can write using variables, constants, numbers, operations, and grouping symbols. And you're pretty much allowed to use anything except the equal or inequality sign. And again, expressions are the building blocks in algebra and precalculus. So there are 2 tasks that you should know how to perform. Generally speaking, you should know how to evaluate any expression, and you should know how to simplify an expression. Of course, this is where it gets tricky because there are many different types of expression. To simplify each expression means certain things that you should know. Now, expressions, I think I already addressed this. All right, so equations. What about equations? Equations are, on one hand, it's 2 mathematical expressions set equal to one another. And what do we do with equations? We try to solve them. What is a solution? Solution is any number or collection of numbers that make an equation a true statement. What does it mean to solve? Once again, that means we're looking for all such solutions, to which we refer to collectively as the solution set. Now, there is a relation between equations or rather the solution set to an equation and the solution set to inequality, which we explored in the algebra review video. For right now, all you need to know is that how to solve each of the different types of the equation. So we will discuss that later. Now, generally speaking, what's in our toolbox when it comes to solving equations? We solve equations by applying the properties of equations, some of which are listed here. Now, without knowing functions, you may not necessarily know what are the relations here. You may see it as a collection of a number of properties, but you also remember that in addition to these properties of equations, there are the ones where, for example, inequalities, why you can add a number to both sides, but when you multiply by a negative number, you have to flip the inequality. So there is more to it than just a number of properties or rules. Knowing functions will help us to see much deeper than we are able right now. Anyway, let's move on. So again, remember, I'm just going down this list. We already talked about operations, expressions, and equations. Next, I'm going to briefly give you an overview of each of these lines. And the first one is a form. What exactly are we going to discuss when it comes to a form of a function? Well, by now you should know that functions are examples of relations in which for each input there is only one output. And when that's the case, a lot of times we can isolate that output in the equation, and by doing that, we'll create a function written in its explicit form. However, it doesn't mean that every function can be written in explicit form. Some of the functions are not, and those functions we call implicit functions. I don't think we spent too much time in algebra talking about those functions, but we will discuss more of that in calculus for sure. So for each type of the function, you should know what is considered to be the standard form for that function. Now, graphing is easy. You just need to know how to graph. When it comes to graphing, the easiest way to graph is by throwing in input into the function and creating this table, input-output, and each pair of values of corresponding input-outputs creates a point which you plot, and by plotting all such points, you create what we call the graph of a function. Now, you can always use technology, but guess what? Technology actually does this. It just does it much faster and than any human would do. But as I say here in the notes, there is no shame in doing graphs by points. So you should be able to graph a function given its equation. Now, once you have the graph of the function, well, also, by the way, for some functions, you should be able to produce the graph analytically. So for example, and most of the functions that we learn in algebra are such that you should be able to do them analytically, meaning without a calculator. However, there is nothing wrong with just using a calculator. It's better than nothing. Now, once you have the graph of a function, you should be able to identify its domain and the range. So domain of the function is the set of all inputs, the range of the function is the set of all outputs. And from the graph, you should be able to see it, just like that. Now, analytically, you should know that since functions, the predecessor of a function is operations, domain is usually obtained by analyzing the restrictions on each operation involved. So here's the list of operations and restrictions. So you should know that in the logarithm expression, the input has to be positive and the base has to be positive. We don't put negative numbers inside of the even indexed radical. and the base cannot be negative in the exponential expression with the negative exponent, because negative exponent means division, and we don't divide by 0, as we know from arithmetic. Now, operations like addition, subtraction, multiplication, and absolute value do not have any restrictions. However, some of the trigonometric operations do have some of the restrictions, and although a lot of them appear to be unary operations, some of them can be expressed as the quotients of others. I'm referring to tangent being the ratio of sine and cosine. So even though it may seem like you just have to memorize the domain of tangent function, it actually naturally comes out of the fact that cosine is in the denominator and cosine cannot be negative. So all you have to do is find where it's, sorry, I said negative, I meant to say 0. So to find the domain of the tangent, all you have to do is to find where cosine is equal to 0. Now, what do we do with all of those restrictions? We set them up in this inequality. It's called compound inequality. So we find the domain by solving this compound inequality in general. However, at this level, we probably never going to see anything too complicated. Now, we're not interested in finding the range analytically. It's just not what we are interested in. And generally speaking, it's not that simple. However, from a graph, you should be able to figure out the range. Now, again, given the graph, you should be able to find the intercepts. There are two types of intercepts, x-intercepts and y-intercepts. The y-intercepts are the values where x is equal to 0. So you find y-intercepts by simply evaluating the function. Now, x-intercepts are the values where y's are equal to 0. But when you set y equal to 0, you end up with an equation. So remember, to find the x-intercepts, you really have to be good at algebra for the corresponding types of functions. So if you don't know how to solve quadratic equations, unfortunately, you won't be able to find x-intercepts of a given quadratic function. You can have as little as none of the x-intercepts, and you can have as many as infinitely many x-intercepts. However, a function can have at most one y-intercept. That's just by the definition of a function. Remember, a function has a single output for each input. So it is possible for you to have two values when x is equal to 0. Now, given the graph of the function, you should be able to analyze the asymptotes. There are three types of asymptotes: and vertical, that we express with an equation of a vertical line; horizontal, that we express with an equation of a horizontal line; and slant asymptotes, which we express with an equation of just a line. Asymptotes could be of higher degree, so certain polynomial functions may behave like parabolas. Certain rational functions may behave like hyperbolas, I guess. And in general, asymptote can be non-linear, but at this level, linear is as far as we'll go. All right. Given the graph of the function, you also have to be able to discuss its monotonicity. So monotonicity, it's the type of behavior that can be described as increasing or decreasing or constant. Here's like a proper definition, but again, looking at the graph, it's pretty intuitive when it's increasing, when it's decreasing, when it's constant. And we always go from left to right naturally. And functions that are only increasing or only decreasing are called monotone. And if the function is not monotone, it may have turning points, or it may change the behavior at a vertical asymptote. And why are we interested in monotone functions? Because monotone functions are one-to-one, and if a function is not one-to-one, it can always be broken down into one-to-one components, and each component can be analyzed individually. Why are we interested in one-to-one functions? Because those are the ones that have inverses, and that's a nice property. Speaking of one-to-one, once you know that a function is one-to-one, you should know how to find its inverse. To find the inverse, we follow these steps. You swap x and y in the function, and then you solve this resulting equation for y. And once you're done, you end up with a definition of an inverse function. And here's the note that I brought up earlier, and basically saying that if a function is not one-to-one, it can be written as a one-to-one piecewise function. And this is one way to define inverse function. Alternatively, we can define an inverse function using a composition of functions. All right. Next, once you have a graph, you should be able to discuss the symmetries. There are two special types of symmetries. Functions can be called even or odd. Here's the definition of an odd function, and here's the definition of an even function. Visually, it's easy. However, you should be able to do it analytically as well. In case if you don't have a graphing calculator in front of you. Now, some graphs have symmetries which are neither odd and even. Some graphs may have axis of symmetries like parabolas that are away from the y-axis. They still have axis of symmetry, but we don't call it even nor odd. So you should know that for each of the function. Now, each function has something special about it that's worth mentioning, and you have to know at least one fun fact about each of the function types. Now, frequently, you don't have a function until you create it, and to create a function, like you have to know how to. So, for example, if the function has been identified by a number of points, so you don't have the graph of the function, but you do have just the points, you should be able to figure out the equation of that function most of the time. So at least you should know what it takes to find the equation. And the rule of thumb is that if in the equation of your function there are n parameters, then you need exactly n points. That's the rule of the thumb. So for example, if the straight line has equation f of x equals mx plus b, how many parameters are there? M and b. So you need 2 points to figure out the equation of that line. Now, points is not always what's given. Sometimes you may be provided some features, such as you may not be given a point, but you may be given the coordinates or the equation of the asymptote. So in some cases, you should know how to use that information to produce the equation. Now, remember, we're not learning all this just for fun. We're learning functions so we can use them in applications. Roughly speaking, an application is pretty much like any word problem that uses one way or another that function. And here's a step-by-step approach to solving all the word problems. I'm not going to bother you with all the details, but you got to read the problem maybe several times to understand it. You got to introduce the variables. You got to create functions somehow, right? This is where comes the skill from the previous slide, like finding an equation. You may have to spend some time finding the equation to create this function. Now you have to identify the question asked in the problem and relate it to what you just created somehow. So this table kind of provides you a little translation from English to math. So for example, to find an output for a given input translates into evaluating the function. Finding the y-intercept means this. Finding the x-intercept means that. Finding minimum of the maximum translates into something that we probably spend a lot of time doing in calculus. Once you identified the question and the solution method, you solve the problem. And at the very end, don't forget to answer the question that was asked in the complete sentence. So this is my guide to applications. And you should know at least one application for each type of the function. Some of them are superficial, but you still need to know it. To summarize, this is vocabulary that we kind of picked up during the pre-calculus, and it's all related to functions. You definitely should practice this vocabulary to make sure we all speak the same language. this concludes my review of I guess it's not the review itself, but it's a preview, because next I'm going to create a review for each type of the functions other than trigonometric ones, because I discussed those already in the video called Trigonometry Review. So next I'm going to create a sequence of 8 videos, one for each type of the function. If you have any questions, feel free to reach out to me.